Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Reduction of cyclic alkynes can give either cis-alkene or transalkene depending on the reagent, and cyclic constraints determine the actual product. Moving on to the next step. Identify reactant P. P is cyclooctane, an 8-membered ring containing a triple bond, CC, with the remaining carbons represented as CH2, 4. Moving on to the next step. Identify products Q and R. Q is the CIS, Z, cyclooctene, the 8-membered ring with a CIS double bond, shown with both H atoms on the same face. R is a bicyclic compound, specifically, trans-cyclooctene cannot exist as a stable isolated ring in an 8-membered system in a planar sense, so the trans-reduction product under Birch, dissolving metal, conditions would normally give transalkene. However, in cyclooctane, the trans-cyclooctene is actually stable enough to exist, but the image of R shows a bicyclic, fused ring structure, suggesting R is the product of a different pathway. Re-examining, R appears to be bicyclo 6.1.0 type or a carbene-derived product. However, in the context of this problem, the key distinction is. And for the final step. Reagent analysis. Reagent 2H2PdCaCO3, Lindlar's catalyst with quinoline. This is Lindlar's catalyst, which performs SYN addition of H2 to give the cis-alkene, Q, cis-cyclooctene. Reagent I2-nalic. NH3, this is Birch, dissolving metal, reduction, which gives trans addition to alkynes, yielding the transalkene. For cyclooctane, the trans-cyclooctene product is actually the observed product, corresponding to our reagent, 3,2H2PdC, complete hydrogenation to the alkane, cyclooctane, not Q or R match reagents to products. Reagent I-nalic.NH3, trans-selective reduction gives trans-cyclooctane is equal to R. This matches option C. Reagent 2H2PdCaCO3, quinoline, Lindlar's catalyst CIS selective reduction gives cis-cyclooctane is equal to Q. This rules out option D, which claims R from reagent 2, and option B, which claims both R and Q from reagent 2. Option A claims Q from reagent I, but reagent I gives trans product R, not Q. So, A is incorrect. Conclusion. Only option C is correct. R, trans-cyclooctane, is obtained on treatment with reagent I-nalic. NH3, dissolving metal reduction giving transalkene. Therefore, the correct answer is C. Therefore, the correct answer is option C.